Now, previously we were looking at tree diagrams, and we're going to revisit those as we look for patterns to come up with some counting principles. And so if we consider an example where we have a jar containing three balls, one red, one blue, one yellow, and we're going to remove three balls one after the other. We want to know what the tree diagram is going to look like if, first of all, the balls are replaced after every selection. Well, if we're going to do that, then on our first selection, we can choose red, blue, or yellow. Now, because the ball is replaced, if we select red first, we still can have a red selected second because of the replacement. So we had 3 outcomes possible on the first draw, and so now we have 9 outcomes possible on the second draw. And if we have one more selection because of replacement, then we're going to have a grand total of 27, or the other way we could have done this is by looking at, there were 3 outcomes, so the number of outcomes would be 3 times 3, so there are 3 outcomes on the first selection, 3 outcomes on the second, and 3 outcomes on the third. So that's a total of 27 possible outcomes, and you can see them all here. Now, the second example, we wanted to know if the balls are not replaced after every selection, how many possible outcomes there are. Well, if we select red on our first, then if there is no replacement, then we can't select red on our second. So we only have 2 possibilities, and that's if we're going to select blue or yellow. So we can have blue or yellow. And if we select blue first, well, we can't select blue second because of no replacement. So again, we could have yellow on our, we could have red drawn first, or second I should say, if we draw blue first, or we could draw yellow second if we drew blue first. And lastly, if we draw yellow on our first selection, then we can only select blue or red on our second. So there. So now, if we select blue, blue on our second after selecting red, we only have one possible outcome now. We can only select one and I'll fix that up. This should be red. So now if we select red and then blue, then our last one we could select is yellow. And if we select red first, yellow second, then we can only select blue third. And if we select blue first, red second, then we can only select yellow. If we select blue, yellow, then we can only select red. If we select yellow, blue, then on our third, we can only select red. And if we select yellow, red, we can only select blue. So now, on our third selection, you can see that there's a total of 6 outcomes. And this, we could calculate this. So the total number of outcomes would be 3, because we have 3 possible outcomes on our first selection, then only 2 on our second, and then 1 on our third, which is 6. So we could calculate it that way. So using the fundamental counting principle, the product rule is if the first action can be performed m ways and the second action can be performed n ways, then there are m times n ways to do both. And in the first example, there were three ways we could select the ball. So there's three, and then our second selection, there's still three, and on our third selection, there's still three. So it's 3 times 3 times 3. And if we take a look at when we don't have selection, then it'll be 3 times 2 times 1 is the number of ways that we can select the balls.